Good evening. My name is Tran. My Panther ID is 6161585, and this is Lab 1 experiment from the EEL 4304L class. So the purpose of this class is to observing the different scenario and plotting the observations. This lab is about the dominant pole model, slew rate and voltage and current constraints. So as the requirements is 1 kilo ohm resistor and one of the 100 kilo ohm resistor and one op amp, wide variety size. As you can, here's the procedures. The circuit diagram design here, I use the N714 diode and connected the following. R1 and R2 are connected to the OP amp. So as the questions one, try to make AV close to 10, 100, 10 to the 3, 10 to the 4, and 10 to the 5th. How high can you go? So as you can see here, the maximum output depends on the DC input for OP amp. The DC source is 30p to p, so the maximum for my DAC is like negative and positive, minus and plus 15. The output voltage acquired as 30 volts. Therefore, the AV is equal to 300 as the maximum. So go to question 2, design inverting amplifier with a gain of negative 100 at 100 Hz. Circuit diagram using multisims. This is the multisim created using the op amp connected to the voltage 1, the R1, the voltage 2, the R2, and with the oscilloscope, the oscilloscope and the XFG1. The output results are acquired by running the above circuit come as predicted. The output gives an expected sine wave, give our PP result. Here is the 10 megasexton per div. Circuit using the MIDAC. According to the circuit diagram, I connected the wire as mentioned in the figure below. So here are the MIDAC that I used to connect to the figure. And here is the result applied using the lab view. As you can see, it comes out at 100 Hz, and yeah, this is the oscilloscope shown in the lab view. The results state that as you increase the input, there will be a point where both input and output will get clipped. But as you keep increasing the input, the small output sign is getting. So let's come to number 3. As you increase the input signal, the slew rate looks like a square sinusoidal. This is because the higher frequency, the higher the frequency, the output does not follow the input. Hence, it looks like this as follows. This is the predicted slew rate. Here is the output produced by oscilloscope. So the graph shown here is what is expected. So as I predicted, the output here shown a better pictures of a non-smooth sine wave. The top of the sine curve is square. For the same amplifier as number 2, reduce the value of R2 until the OP-amp will be the current limit. As you can see here, I used the same setup as the last time, but reduced the R2 to 5 kilo ohms. And the output comes here in the result. It's a sinusoidal wave. Let's come to the number 5. What is wrong with the following circuit? As you can see here, the R1 and R2 and 1 and 2 ohms respectively are wrong in the circuit. The lowest resistance can be used in this op-amp circuit is 5 ohms and 10 ohms. Anything lower than that will not limit the current. Conclusions: as operational amplifier is a DC coupled high gain electronic voltage amplifier with a differential input and usually a single-ended output. In this configuration, an op-amp produces an output potential relative to the circuit ground that is typically hundreds of thousands of times larger than the potential difference between its input and terminal. Thank you. This is the end of the lab 1.